Alright, here goes nothing. I don't know how to record this properly, so we got a little setup here. This is the z-axis up and down, x-axis left and right. I put a rubber band on this ball that I found. That's going to represent the potential x rotation. So any point on this line around the sphere is a x coordinate. So like this would be 180, this would be 90, this would be 270. The idea is that you would think that the x-axis, or the z-axis rather, um, would be like this. And it would be if the x-axis is 0. I shouldn't say axis. The x rotation is 0 or 180. You would have a line around here, and this would be all potential z rotations. But what happens is the x rotation is calculated first. So just because it's where the camera is pointed, this is the top, that's 180. Let's say that this is 130 right here. If you have x-axis, x rotation in the x-axis at 130, the z-axis rotation exists like this. I'm just going to hold that in place there. Basically, it's aligned this way with the z-axis. Like you take a cross section, you cut this here, and that circle that's left when you cut it, the perimeter of that circle is every possible z rotation. So if we put this rubber band on somewhere where it actually stays, let's put it right there. We'll say that this is like, 160 or something, or I suppose like 20 degrees if we're down here. So if the x rotation is 20 degrees rotated, it takes this point, which is 20 degrees on the x-axis rotation, and draw a circle around that point through the z-axis. And that circle is every possible z-axis rotation with that x rotation, because z-axis is done second. So if you had 90-degree z rotation and 20-degree x rotation, you would end up at a point somewhere like this. And what you do with this point is you draw a line from here to the center of the sphere, and that gives you the direction of gravity. If you have a line coming out this way, it's coming out 90 degrees from like the horizontal plane, but it's offset over here. Comes out at like this kind of line. And the closer this gets to 90 degrees on the x rotation, you eventually reach a point where there is no cross section you can take here. There's just a point. And any rotation around here is identical to the y-axis rotation, which I don't know if it's technically calculated last, but I think of it last. And let me just grab something round real quick. So you could imagine if you have x rotation of 180 completely upside down, this cap that I'm placing on here, the perimeter of this, get my hand out of the frame, is every possible facing angle. But that has nothing at all to do with gravity rotation. The gravity rotation is this point here. Down is pointing straight up, but you have a circle about this space of which facing angle could point any direction. So when you're at 90 degrees and you put this cap on the side here, you can have a facing angle anywhere around this circle, but your gravity angle is pointing straight 90. And the z rotation can't change the direction gravity is pointing, so it only affects facing angle. If you have something that's like, again, like 20 degrees or something here, with this cross section through the z-axis, this is every possible z-axis rotation, and every point on here corresponds between 0 all the way up to 1, or 360, I suppose. 180 would be when it crosses again, which is, gravity is essentially identical between these 2 points where this crosses, except in one case your character is falling with negative v speed, and with one case they're falling with positive v speed, but terminal velocity will be the same. So at this point you could stick this circle on here and think of this perimeter as every possible facing angle from that rotational point. But the x and z points are the only ones that determine gravity. And then, well, that's kind of the basic gist, actually. You basically have a sphere with a line around it in the x-axis, and you slice that sphere 65,000 times, and every single unique slice corresponds to an exact x rotation, and the perimeter of each slice corresponds to that x rotation with every single possible z rotation. Each point along each slice corresponds to a specific z rotation, and what down is from the combination of two xz points is, if you draw that on the sphere as a point, it's the line from the center of the sphere, which I can't touch, but you have to imagine it. The line from the center of the sphere to that point is where gravity is facing at that point. That's the way that I try and think about it. And it makes a lot of sense when you look at Gimbal